Welcome back. Today we are going to be going through lesson 4.4, which is about solving quadratic equations by factoring. So first of all, let's remind ourselves what solutions of quadratics are. What are we trying to find here? So those are the points where the graph is intersecting the x-axis. Sometimes they are also called roots, and you'll see why in another lesson. They are also called x-intercepts, which is what we're going to focus on today. And they are also called zeros. So there are three situations that can come up when we're solving quadratics. We, again, because they're x-intercepts, we can have quadratics that have no solution. So that is where our parabola never intercepts the x-axis. We can have one solution, and that's where the parabola touches the intersection once, that x-axis, and just has one solution. And then finally, we can have what's most common, which is where parabolas have two solutions or two x-intercepts. So it's crossing twice. Okay, so looking at these graphs, take a second and identify where their solutions are. So this first one, we can see that it intersects twice. We have an intersection at -4. And we have one at 0. So those would be the two solutions. This second one has an intersection just at +4. So the x value of the solution is just +4. And this last one, we can see it has two solutions again. One of them is at 2. And the other one is at 6. So that's what we're looking for when we are solving quadratics. Today, we're going to go through the process of factoring quadratics to find those solutions. So rather than looking at the graphs, we are going to look at them in factored form to find the solutions from the equation. So when we are solving by factored form, we are trying to get our quadratics into what is called intercept form. So intercept form looks like y equals a, so just a number, times x minus p and the quantity x minus q. So that's the form. It's called intercept form. It's also sometimes called a factored form. So when we're factoring, we're trying to get it into this form. When I do that, I can identify my x-intercepts easily, and that's what we're trying to do here. So when we are factoring, there's 4 main steps, and then each type of factoring we do is going to have slightly different steps. So step 1, we're going to get the quadratic equal to 0. That's where that name zeros comes from. We want to know, when does the quadratic equal 0? Then we factor it using a variety of different methods. And then we set each factor individually equal to 0 and solve for x. And those are our solutions that we're going to write in set notation, which is how we were writing them up above. So the first kind of factoring that we have is just what we call GCF, or greatest common factor. So when we're factoring out a GCF, or a greatest common factor, we're just trying to find out what is common among the terms and dividing it out. So in this case, I can see that these two terms both have an x. So I am going to factor that out. And when I factor that out, it leaves me with an x in the first term and a -7 in the second term. So then we take each factor and set it equal to 0. So when I take x and set it equal to 0, that means that my first solution is just 0. And when I take x minus 7 and set it equal to 0, that would tell me that x is 7. So those would be my two solutions. For b here, same thing. We want to figure out, when does this equal 0? So 3x squared minus 12x. Again, I'm looking for that common factor. So in this case, I can divide out a 3 from both 3 and 12, and I can divide out an x. So that is my GCF. When I do that, I'm left with an x minus and then a 4. So those are my factors. Now I'm going to set each one equal to 0 to find my solutions. So 3x equal to 0, that means that x is 0. And x minus 4, when I set that equal to 0, that means that x is 4. So those are my two solutions. Okay, let's move on to another type of factoring that we need to know how to do, and that is our basic method. So the first thing you're going to notice is that in the rest of our types of factoring that we're going to do, the first step is always going to be to look for a GCF. So no matter what, we're going to do that first. When we are factoring out a GCF, one thing that we're always making sure we're doing is that when we're factoring using the basic method, the A value always needs to be positive. So even if we're just factoring out a negative to make it positive, we need to factor that out. Okay, so on this first one, I can see that I have that negative out in front. I need to get rid of that negative. So the first thing I'm going to do is I am going to factor, well, first thing I'm going to do is I'm going to set it equal to 0. So I'm going to say 0 equals negative x squared minus x plus 42. Then I am going to factor out that negative because I want a positive a value. So I'm dividing each term by a negative. And that's going to be what it looks like with the GCF factored out. Next, what we're going to do is we are going to find the factors of C that add up to B. So we're trying to figure out if we take the C value and we factor it into two factors. I want to know what factors of C will add up to B. So in this case, we're trying to figure out the factors of negative 42 that'll add up to positive 1 because that's the coefficient on B. So when I do that, I go ahead and leave my GCF out in front, and then I'm going to write those factors inside the parentheses. So x squared, we can factor into x times x. And then the factors of negative 42 that add up to 1 would be positive 7 and negative 6. So 7 times negative 6 is negative 42, and 7 plus negative 6 is 1. So once I have that, I set each one equal to 0 to find my solutions. So if I take x plus 7 and set it equal to 0, x is negative 7. And if I set x minus 6 equal to 0, x is 6. Okay, let's try another one like that. So on this one, I can see that 2 out in front. So I'm going to set it equal to 0, and I'm going to factor out that 2. So dividing each term by 2, it's going to leave me with x squared plus 10x plus 25. And then again, I'm looking for the factors of 25 that add up to 10. So I leave my GCF out in front, and I'm writing my factors out. So 25 is 5 times 5, and those add up to 10. So when I take each of those factors and set it equal to 0, x plus 5 is going to give me a solution of negative 5, and they're the same factor, so this one only has one solution. Okay, let's take a look at our next method. Again, you'll see that the very first step is to always look for a GCF if there is one. And then we do what's called the slip and divide method. So you're going to multiply A and C together. Remember, that's the first and the last coefficient. That gives you a new C term that you're working with. You're going to factor it using the basic method that we just did. And then because we multiplied A and C, we need to divide it by A out again. Simplify anything that I need to. And then write our factors. The denominators are your firsts and the numerators are your lasts. So let's take a look at what that looks like. So in C, I do not see a GCF. I have a 3, but that doesn't divide into 14. So no GCF. I'm just going to set it equal to 0 to start with. Okay, now, again, I'm going to multiply the A times the C value, and that is going to leave me with x squared. So we move it off the first term, minus 14x, and now my new C term is negative 15. Then we're going to factor that trinomial again. So we're looking for two things that multiply to negative 15 and add up to negative 14. So that would be x minus 15 and x plus 1. Now you're going to divide the last term in each of those factors by that a value we started with. So our a value is 3. So I'm going to divide that by 3. And when I do that, this one on the left side, that left factor, simplifies to 5. So that's the simplifying part. 1/3 I cannot simplify, so I'm just going to leave it. So my factors are going to be x minus 5. And then this one, I can rewrite, instead of x plus 1/3, I can take that denominator and shift it to my first term. So that's going to be 3x, and then the numerator stays as my last term. So I can factor it that way. When I set those equal to 0, I'm going to get x values of 5, and then I'm going to get an x value of negative 1/3 for that last factor. Okay, let's take another look at this. So in this one, I have 30, 27, and 6. Those are all divisible by 3. So I am going to start by setting it equal to 0 and factoring out a 3 from each of these terms. Okay, so now I've done that. The next thing I'm going to do is I'm going to multiply that a and c value together to get a new c value. So I'm going to slip that towards the other end so that I don't have an a value anymore. That's going to give me a c value of 20 now. Then I'm going to factor it using the basic method. So factors that multiply to 20 and add to 9, that's going to be 5 and 4. You need to add up to negative 9, so it's going to be minus 5 and minus 4. All right, now since I multiplied that a value in, I need to divide it back out now to keep it even. So I'm going to divide by 10 on both of these. For this first factor, that's going to reduce to 1/2. And this one is going to reduce to 2/5. So when I write my final factored form, remember the denominator becomes my first coefficient, and the numerator is my second. And then same thing here, the 5 becomes my coefficient in the first part, and the 2 is my last term. All right, so my solutions here are going to be 1/2 and 2/5. All right, let's talk about one more method, and then we'll get into some practice problems. So this one is the difference of two squares. So this is a unique case where we have a very specific thing going on. So if you look at the examples, you can kind of see it's missing that b term. So that when we say difference of two squares, it's where subtraction is happening between two things that are perfect squares. So we're still going to factor out a GCF if there is one. And then we're going to square root a and c, because they're perfect squares, and use those to create our factors. So set it equal to 0. This first one does not have a GCF of any sort. So I'm going to square root both a and c. And that is going to give me x minus 4. And since they're perfect squares, that means my other factor is exactly the same. The only difference is if I want them to multiply to negative 16, I have to make one of them positive and one of them negative. So my two solutions then would be negative 4 and positive 4. All right, let's do another one. So looking at these two perfect squares, 4 and 81 do not have a GCF. So I'm just going to set it equal to 0 and leave everything the same. Then I'm going to square root my a and my c. So when I square root, I'm going to get 2x and 9. And then remember my other factor, is 2x plus 9. So we want them to add to 0. So one has to be positive, one has to be negative. And I want them to multiply to a negative. So my two solutions here are going to be negative 9/2 and positive 9/2. Okay. So looking at our practice page here, we are going to go through and practice these. I would encourage you to pause the video and try them on your own and then come back and check your work. So for this first one, looking at it, it's not perfect squares. I don't have an a value where I need to slip and divide, so this is just going to be the basic method. So I'm looking for two numbers that multiply to 9 and add to -10. So that's going to be -1 and -9. So my solutions are going to be +1 and +9. All right, looking at number 2, I can see that 4 and 36 and the x all have a GCF. So I'm going to start with GCF and see what I'm left with and see if I need to do another method after that. So dividing out their common factor, which is 4x, that is going to come out in front. And I'm going to be left with an x and a -9. So looking at that, I have no quadratic left in there, so I don't need to do any other methods. I can just find my solution. So the solution for 4x is 0, and the solution for x minus 9 is 9. Okay, so looking at this one, I notice that it's not equal to 0, so the first thing I'm going to do is I'm going to get it equal to 0 so that I can kind of see what's going on. This one, no a value out in front, no GCF, so I'm just going to do the basic method here and see if I can find multiples of -35 that add up to -2. So my factors would be 7 and 5. If I want them to add up to -2, I need -7 and +5. So my solutions are going to be 7 and -5. Okay, looking at number 4 here, it's also not equal to 0, so I'm going to move that x over, write it in standard form, and now I can see that again I'm going to do the basic method. Nothing fancy on this one. So my factors that multiply to -2 and add up to -1 are going to be -2 and +1. So those solutions are going to be 2 and -1. Okay, looking at number 5 here, I notice that all of these have a common factor of 2. So I am going to factor out that 2 first with a GCF and then see if there's anything else I need to do. Okay, so on this one, I see that I still have a quadratic in the parentheses. Excuse me. So I'm going to need to do some more factoring. It's a basic quadratic, so I'm going to do the basic method on what's left. So multiples of, or factors of 10 that add up to 7, that's going to be 2 and 5. So my solutions are going to be -2 and -5. Okay, number 6. So on this one, I got to get it equal to 0 first to kind of see what's going on. Okay, so I can see right away that there's a negative out in front, so I'm going to take out a GCF to start with and then see what I'm working with. So I'm just going to take out the negative to make that a value positive. Okay, so now I can see that quadratic is a basic one, so I'm going to do the basic method to finish factoring that. So factors of 100 that add up to -25. That's going to be -5 and -20. So my solutions are going to be 5 and 20. Okay. Moving right along here, number 7 is not equal to 0, so I'm going to get it equal to 0 first to see what's going on. Okay, so I can see on this one that there's not a GCF, but there is that A value out in front. So in order to help alleviate that, I am going to slip and divide. So I'm looking at when that A value is greater than 0, and I can't divide it out. All right, so slipping and dividing, we are going to multiply that A times C value. So slip that down there. That's going to leave me with a C term of 9. Then I am going to do my basic method. I'm going to get a little squishy here. Factors of 9 add up to 6 would be 3 times 3. Remember, I have to divide it by that A value. So my factored form, I'm going to write it over here where I have space. So when I reduce these is 1/3. So in this one, when I write my factors, I'm going to, remember, move that denominator in front. That's my coefficient on the first term. And then the numerators at the end. And these ones are exactly the same. So I'm going to write that as 3x plus 1 squared. And that means that my solutions are negative 1/3. So that one only has one solution. Okay, let's look at number 8 now. Get it equal to 0 so I can see what's going on. And I can see that there's no GCF, so I'm going to have to slip and divide to take care of that A value out in front. So multiplying that 2 by negative 6, I get, oops, not 2x squared. We're getting rid of that. We have x squared minus 11x minus 12. When I factor that using my basic method, I get x minus 12 and x plus 1. Divide that A value out that we multiplied originally. So when I do that, this reduces to just 6, and that's 1/2. So my factors are x minus 6 and 2x plus 1. So that means that my solutions are negative 1/2 and positive 6. Okay, last two methods here. Last two problems. Let's get this equal to 0 first. This one, I noticed that 9 and 49 are perfect squares. So this is a difference because we're subtracting of 2 squares. So I can use that method of square rooting the 2 squares to find my factors. So when I do that, my factors are going to be 3x plus 7 and 3x minus 7. So my solutions are going to be negative 7/3 and positive 7/3. Okay, last practice problem here. So on this one, I notice that there's a GCF. So both of those terms are divisible by 25. So I'm going to take that out first and then see what I'm working with. And when I do that, the quadratic that's left in parentheses, I still have to factor. And I notice that x squared and 4 are both perfect squares. So I'm going to do difference of squares again. This one. So I'm doing it with just the quadratic that's left inside the parentheses here. So the 25 stays out in front. And when I square root, I get x minus 2 and x plus 2. So that's my factored form, which means my solutions are negative 2, set notation, are negative 2 and positive 2. All right, that is your review of factoring. We'll see you next time.